So in this video, we are going to look at the basics of reaction equations. So what are the different parts of a reaction equation and how can we represent it? So let's start with just a generic reaction equation here. So there are two main parts. We've got the piece that's on the left side of an arrow, and we've got a piece that's on the right side of an arrow. Okay, so main components here first. This left side of the arrow are called the reactants. And you can have 1, 2, 3, 4, 5. You can have as many reactants as you need for that reaction. Over here on the right side of the arrow, so the after, are the products. So reactions are always written as we read them from left to right. Reactants are what we start with. Products are what we end with. This arrow here in the middle is what we say that something is produced, created, transformed, etc. So the arrow represents the reaction actually happening. Okay, so we have our starting ingredients, reaction happens, we have what we end with. Okay, so on either side, we have our chemical formulas. Okay, I'm gonna add something to my reaction here really quick. I'm gonna add that number 2 here in front. Okay, we'll get to that number 2 here in a second. So I have in my reaction, 2's not included, there we go. My chemical formulas. Okay, so let's talk about our chemical formulas. Okay, so it has the element symbol, so those would be A, B. If we wanted to include actual elements, it would be things like hydrogen, oxygen. We could have chromium, Cr, so any of our element symbols that we would find on our periodic table. And then we also have our subscripts. Okay, so our subscripts, like here, is our 2. And so that's going to tell us how many of that element we have. So, for example, in AB2, that is made up of 1 atom of element A and 2 atoms of element B. And then that's how we write it as the chemical formula. So AB2, which is how we would read it, has 1 element A and 2 of element B. Okay, so we've got our reactants, our products, we have our chemical formulas have our symbols and our subscripts. Now, let's talk about this guy here. Okay, so this big number in front is called a coefficient. And you might, just realize that you can't see that. I wrote that too high for my camera. Let's angle that up just a little bit. There we go. Maybe not the most flattering view, but we're gonna go with it. Coefficient. Okay, so coefficient, you might recognize that term from math class. Okay, so it's the big number here. Instead of coming in front of a variable, it comes in front of an element symbol or a chemical formula. So the coefficient tells us one of 2 things. So it tells us number of particles or number of moles. So a mole is just a lot of particles, specifically 6.02 times 10 to the 23rd. Okay, so we would look at this reaction and there's a 1, a 2, and a 1 in terms of our coefficients. So this tells us that we have 1 particle of element A reacting with 2 particles of element B to make 1 particle of AB2. We could also substitute in moles if we wanted to think on a much bigger scale. When we write chemical reaction equations, we can change these coefficients to make what we call balanced chemical reaction equations, and that's something that we're going to get to later. So if we go back to our reaction equation, we've got our reactants on the left, our products on the right. Our arrow is the action of the reaction occurring. We've got our chemical formulas, which are made up of element symbols and subscripts if needed. Our subscripts tell us how many of each type of element we have. And then we use coefficients to do what we call balance our chemical reaction equations, which we're going to talk about later. And our coefficients tell us number of particles or number of moles. The last piece is that oftentimes you'll see included in chemical reaction equations a symbol afterwards, after the chemical formula. That might be an S in parentheses, an L, a G, or an AQ. Okay, so if you've got any of those symbols after, these tell us the states of matter. Okay, so S would be solid, L would be liquid, G would be gas. AQ isn't a state of matter, but it stands for aqueous, which just means that it's dissolved in water. Okay, so if we had symbols after this, so if we had A and then in parentheses S, and B in parentheses AQ, and here at the end, if we had in parentheses AQ, I know that I would be reacting solid element A with element B dissolved in water, and I'd get a solution at the end of AB2 also in water. So those symbols at the end tell you what your states of matter are. The last piece to this is another way that we can represent our reaction equations, which is using particle diagrams. So I'm going to take a minute and I'm going to erase these pieces. Okay, so in my particle diagram, I'm gonna have a key. I'm gonna have a box for my reactants and a section for my products. Okay, so I'm gonna start by making a key for each of my elements. So I've got two elements involved. I have element A and element B. I'm gonna say we're gonna represent element A with a triangle and element B with a circle. When we're drawing these particle diagrams, we're keeping them nice and simple. We're not drawing Lewis structures. We're not worried about showing bonding. I like to use symbols or colors to represent our elements. So we're keeping it nice and simple here. I'm gonna tip this down just a little bit. And that didn't help with the glare like I thought it was going to. Anyway, our reactants. So our equation says we have one A, so I'm gonna draw one triangle. And we have two of element B, okay? So I'm gonna draw two circles because I said A was a triangle and B was a circle. And then in my products, I have A, B, 2. So they're in one molecule or one unit, so they're gonna be connected. Both my A and both my B's are gonna be connected together. So how you arrange them doesn't matter. I'm just gonna arrange them in a line like that. So notice in my reactants, they're all nice and separate because they're two separate entities, and then there's a 2 here. So these aren't connected. So I've got two separate things combining together to make one product at the end. So that's how we represent reactions using a reaction equation and using a particle diagram.